Prove that the finite Hankel transformation of f of x lies between 0 to 1 is p power n minus m jm of p, where f of x is equal to 2 power 1 plus n minus m by gamma m minus n into x power n 1 minus x square whole power m minus n minus 1. We know that from the definition of Hankel transformation, hn of f of x, which is equal to integral 0 to a f of x into jn of px dx, that is equal to replacing f of x by 2 power 1 plus n minus m by gamma m minus n into x power n into 1 minus x square whole power m minus n minus 1, which is equal to, and the limit of x is 0 to 1, so replacing a by 1, right? Integral 0 to 1 2 power 1 plus n minus m by gamma m minus n x power n into 1 minus x square m minus n minus 1 into x into jn of px dx. That is equation number 1. We know that the jn of x is the Bessel function of the first kind of order n. That is, jn of x is equal to summation r is equal to 0 to infinite minus 1 power r by factorial r gamma n plus r plus 1 into x by 2 whole power n plus 2r. Replace x by p of x, so jn of px, which is equal to summation r is equal to 0 to infinite minus 1 power r factorial gamma n plus r plus 1 px by 2 whole power n plus 2r. That is equation number 2. Using 2 in 1, we will get hn of f of x, which is equal to integral 0 to 1 2 power 1 plus n minus n by gamma m minus n x power n 1 minus x square m minus n minus 1 into x into summation r is equal to 0 to infinite minus 1 power r factorial gamma n plus r plus 1 px by 2 whole power n plus 2r dx. That is equal to 2 power 1 plus n minus m by gamma m minus n, which is a constant, take it outside from the integral 0 to 1 x power n 1 minus x square m minus n minus 1 into x summation r is equal to 0 to infinite minus 1 power r factorial gamma n plus r plus 1 p power n plus 2r x power n plus 2r by 2 power n plus 2r. We are splitting the power to each term into dx. That is 2 power 1 plus n minus m by gamma m minus n summation r is equal to 0 to infinite minus 1 power r factorial gamma n plus r plus 1 p power n plus 2r by 2 power n plus 2r. All these are constant, take it outside from the integration. So integral 0 to 1 x power n 1 minus x square m minus n minus 1 into x power n plus 2r dx. So 2 power 1 plus n minus m minus n minus 2r. We are grouping all the power of 2. So we are having 2 power n plus 2r in the denominator. So it will come to the numerator, it will become 2 power minus n minus 2r. So we are grouping. So 2 power 1 plus n minus m minus n minus 2r by gamma m minus n summation r is equal to 0 to infinite minus 1 power r p power n plus 2r by r factorial gamma n plus r plus 1 integral 0 to 1 1 minus x square m minus n minus 1 grouping x power n plus r, right, into x into dx. So that is equal to 2 power 1 minus m minus 2r by gamma m minus n summation r is equal to 0 to infinite minus 1 power r p power n plus 2r by factorial r gamma n plus r plus 1 integral 0 to 1 1 minus x square m minus n minus 1 x power 2n plus 2r into x dx. That is equal to 2 power 1 minus m minus 2r by gamma m minus n summation r is equal to 0 to infinite minus 1 power r p power n plus 2r by r factorial gamma n plus r plus 1 integral 0 to 1 1 minus x square m minus n minus 1 2 is common, so x power 2 into n plus r into x into dx. So taking x square equal to y, substitution method, right, to evaluate the integration. So 2x dx is equal to dy. Therefore x dx is equal to dy by 2. So when x is equal to 0, y equal to 0. When x is equal to 1, y equal to 1. So this becomes 2 power 1 minus m minus 2r by gamma m minus n summation r is equal to 0 to infinite minus 1 power r p power n plus 2r by r factorial gamma n plus r plus 1 integral 0 to 1, replacing x square by y, 1 minus y power m minus n minus 1, right? X square, that is y, power n plus r, right? X square power n plus r, it can be written as x power 2 into n plus r can be written as x square whole power n plus r. So replacing x square by y, y power n plus r. Then x dx is nothing but dy by 2. So that is equal to 2 power 1 minus m minus 2r, taking that 1 by 2 outside the integral. So by 2 into gamma m minus n summation r is equal to 0 to infinite minus 1 power r p power n plus 2r by r factorial gamma n plus r plus 1 integral 0 to 1 minus y m minus n minus 1 y power n plus r into dy, which is equal to 2 power. So in denominator you are having 1 2, so it will become 2 power minus 1. So plus 1 and minus 1 get cancelled, so remaining you are having 2 power minus m, common, minus is common, minus of m plus r by gamma m minus 1 summation r is equal to 0 to infinite minus 1 power r p power n plus 2r by r factorial gamma n plus r plus 1 integral 0 to 1 minus y power m minus n minus 1 y power n plus r dy, which is equal to 2 power minus m plus r5 r by gamma m minus n summation r is equal to 0 to infinite minus 1 power r p power n plus 2r by r factorial gamma n plus r plus 1 integral 0 to 1 minus y power m minus n, we are grouping m minus n then minus 1, then y power n plus r can be written as adding 1 and subtracting 1. So we are grouping y power n plus r plus 1, right, minus 1 into dy, because we are going to use beta function, right? We know beta mn, which is equal to integral 0 to 1 x power n minus 1 minus x power m minus 1 into dx. And relation between beta and gamma, beta mn, which is equal to gamma m into gamma n by gamma m plus n, right? So that is equal to 2 power minus m plus 2r by gamma m minus n summation r is equal to 0 to infinite minus 1 power r p power n plus 2r by r factorial gamma n plus r plus 1. So this can be written as, so see, 1 minus y power m minus n minus 1, right? 1 minus x power m minus 1. So instead of x you are having y, so instead of m you are having m minus n, right? And instead of n you are having n plus r plus 1. So just you replace in the beta function. So beta n plus r plus 1 comma m minus n, which is equal to 2 power minus m plus 2r by gamma m minus n summation r is equal to 0 to infinite minus 1 power r p power n plus r by r factorial gamma n plus r plus 1 into, so we are using the relation between beta and gamma, gamma n plus r plus 1 into gamma m minus n by gamma n plus r plus 1 plus m minus n, right? So this is equal to 2 power minus m plus 2r by gamma m minus n summation r is equal to 0 to infinite minus 1 power r p power n plus 2r by r factorial gamma n plus r plus 1 into gamma n plus r plus 1 into gamma m minus n by gamma, so n minus n get cancelled, so remaining you are having r plus 1 plus m, which is equal to 2 power minus m plus 2r, because in numerator you are having gamma m minus n, denominator gamma n minus n get cancelled. Similarly in numerator gamma n plus r plus 1, in denominator also you are having gamma n plus r plus 1 getting cancelled. So remaining, which is equal to 2 power minus m plus r summation r is equal to 0 to infinite minus 1 power r p power n plus 2r by r factorial gamma r plus 1 plus m. So 2 power minus m plus r summation r is equal to 0 to infinite minus 1 power r p power n plus 2r by r factorial gamma r plus 1 plus m. So we are multiplying p power m and divided by the same term p power m, right? 2 power minus m plus 2r, summation r is equal to 0 to infinite minus 1 power r p power n. We are splitting the power p power 2r by r factorial gamma r plus 1 plus m p power m by p power m, which is equal to 2 power minus m plus 2r, summation r is equal to 0 to infinite minus 1 power r p power n. So we are grouping p power 2r and p power m, that is p power m plus 2r divided by whole divided by r factorial gamma r plus 1 plus m into p power m, which is equal to p power n by p power m. We are taking that p power n in the numerator and p power m in the denominator into summation r is equal to 0 to infinite minus 1 power r p power m plus 2r into 2 power minus m plus 2r by r factorial, right? Gamma r plus 1 plus m, which is equal to p power n minus m, right? So p power m in denominator becomes p power minus m, grouping that p power n minus m, summation r is equal to 0 to infinite minus 1 power r by r factorial gamma r plus 1 plus m. Then we are grouping p and 2, so p by 2, because 2 power minus m plus 2r you are having, so it will go to the denominator, then it will become 1 by 2 power m plus 2r, so p into 1 by 2, so p by 2 power m plus 2r. Therefore Hankel transformation of f of x, which is equal to p power n minus 1 m. This summation is nothing but jm of p, right? So we introduce the first line itself in this problem, right? Jn of x. Here instead of x you are having p, instead of n you are having m, that is why jm of p, Bessel function of first kind, right, which is to be proved. Therefore jm of p, which is equal to that that is jm of p, which is equal to summation, that is the Bessel function of the first kind, p by 2 m plus 2. Thanks.